Assalamualaikum warahmatullahi wabarakatuh. Okay, today I want to continue our new chapter, chapter 4 on non-uniform flow in open channel. Okay, at the end of this chapter, students should be able to analyze the characteristic of hydraulic jam, rapidly varied flow based on momentum equation, and analyze the characteristic of gradually varied flow. Okay, rapidly varied flow occurs when the depth of flow change rapidly within the short distance. Example is hydraulic jam here. Okay, so hydraulic jam occurs when the supercritical here from the point 1 here, okay, change suddenly to subcritical flow in point 2 here within a short distance. So this is the distance between the Y1 to the Y2 here. Okay, so hydraulic jam occurs when supercritical flow change suddenly to subcritical in Y2. Okay, and YC we get the value for YC, we use the equation in chapter 3. Okay, critical depth. Okay, hydraulic jam occurs when the upstream flow is supercritical. Example is Y1 is less than YC. Okay, and the downstream flow becomes subcritical flow when Y2 more than YC and YC more than Y1. Okay, so where the Y1 is the depth of flow just before the jump. Okay, and Y2 is the depth of flow just after the jump. And Y1 and Y2 are known as conjugate depth. Okay. So this is the example of the hydraulic jam in laboratory flow. Okay, so this is the flow is from this, okay, the blue arrow here. Okay, using the wheel here. So we have learned the flow in chapter 3. Okay, when we get suddenly from the subcritical to the subcritical here, so we get the hydraulic jam. So this is called the hydraulic jam. Okay, so this is the hydraulic jam here. Okay, so this is the hydraulic jam. Okay, so this is the example in the real part of the hydraulic jam at the toe of spillway. Okay, in dam Brazil. Okay, Itaipu Dam Brazil. Okay, so this is the hydraulic jam downstream of sluice gate. So this is the sluice gate from the Heron Canal in Turkey. Okay, so this is the gate here. Hydraulic jam is occurs here. Okay, so and this is the wave hitting seawall in US here. Okay, so this is, so they have in the real cases in this sea, this is the retaining wall here. So the wave hitting seawall, so we get the hydraulic jumps from the supercritical to subcritical, so we get the hydraulic jump occurs. Okay, so also this is also the surge wave due to fast flood in China. So this is the hydraulic jump here because the flow from the state of supercritical to subcritical, so we get the hydraulic jump here. Okay, application of hydraulic jump. So first we use the energy dissipator. Example is to reduce velocity and prevent erosion. Okay, raise the water level for irrigation or water distribution purposes. So and third, increase weight on apron by raising the depth of water to prevent uplift pressure. Okay, and for mixed chemical substance, example in water treatment process, and the aeration of flow increase DO. So this is the application of hydraulic jump. So if in your test 2 or in your final ask you to list or state of the application of hydraulic jump, so you can list down this theory. Okay, the application of hydraulic jump. Okay, type of jump. So based on the front number before the jump. So we use the front number to know that the types of jump. So if the front number is between 1 to 1.7, so this is undulate jump. Okay, from 1.7 to 2.5, so there is the weak jump. 2.5 to 4.5 is oscillating jump. And 4.5 to 9, so this is steady jump. and more than 9 is called the strong jump here. So this is the type of jump. Okay, so this is the figure here. Okay, this is the type of the undulate jump, weak jump, oscillating jump, steady jump, and the strong jump here. So this is the example that the hydraulic jump is occurs in laboratory flume here. Okay, so hydraulic jump, so we use the momentum equation to find the hydraulic jump. Okay, so consider a hydraulic jump on frictionless flat bed within the rectangular channel. So we assume that the channel is types using the rectangular channel here. So this is the momentum equation. Okay, from the momentum equation, so from that momentum, so we dividing by rho GB, so we get this equation until we get the equation for the hydraulic jump here. Okay, so this is okay, no need to worry because this is the theory for the how from the momentum. Okay, so we get the hydraulic jump. Okay, so this is using the activity the momentum force equation, draw the specific force. Okay, actually from the specific force here, so we get the momentum flux and hydraulic pressure. So this is the using the momentum force. So actually the y1 and y2 with the same force are conjugate depth. So from this part, so we get the subcritical flow and the supercritical flow. So we just draw here and we get the y1 and y2 with the same f are conjugate depth. Okay, so to sketch the graph here, so we just put the y until 1, 2, 5. So and then we sketch the graph here until we get the F minimum, so we get the YC. Okay, F minimum with the force minimum, so we get the critical depth. And so we can get the subcritical flow and the supercritical flow. This is the example how to find the subcritical flow and supercritical flow using the graph. Okay, actually this is the conjugate depth equation. Okay, for hydraulic jump, so we use from the momentum equations, so we just use the momentum equation and then we just put it in the conjugate depth here. So we get the conjugate depth equation here. Okay, from the momentum equation of flow in rectangular channel, so we get this one. Okay, rearranging of this one until we get the this is called the conjugate depth here. Okay, so this is to find the y1 and y2. Okay, using the q, and this is using the Froude number to get the state of jump. Okay, the types of jump here. Okay, so from this one, so from that's the first slide, the previous slide, so we division by y1 power of 3. Okay, until we get the real equation that we must use in. So we get this one. Okay, actually this equation is given in your test or in your final. Okay, no need to worry. Okay, just you must know that y2 over y1. So this is Froude number 1. Okay, if y1 is here and y2 is here, so the Froude number is 2 here. Okay, so based on the part here. Okay, so y2 over y1, so the Froude number is Froude number 1 here. Okay, so since y1 and y2 are positive values, so we use this equation. Okay, so no need to worry about that, the above equation here. Okay, just look at this part of the conjugate depth. So this is called conjugate depth. Okay. Okay, so this using the, so if we use the y1 over y2 here, so this is Froude number is 2 here. Okay, so else as if division is made by y2 power of 3, so y2 is part here. Okay, y1 over y2, so the Froude number is 2 here. Okay, so you just change the Froude number here. So actually the real of the conjugate depth is this one. Okay, Okay, so y2 over y1 here. So the Froude number is 1 here. So this is the equation for conjugate depth to find the hydraulic jump. Okay, so note that the hydraulic jump to occurs when y2 over y1 is more than 1. Okay, y1 over y2 is less than 1. So you must remember this basic. Okay, when the hydraulic jump occurs, when y2 over y1 is more than 1, y1 over y2 is less than 1. So we use that conjugate depth to find the y1 and y2. Okay, so this is energy loss. Okay, energy loss in hydraulic jump here. Okay, there will be considered loss of energy in hydraulic jump. Okay, between section 1, okay, to the section 2 here. Okay, so we have the energy loss here. Okay, between the section 1 to the section 2 here. Okay, so we get the y1 here before the jump. Okay, when the hydraulic jump occurs here, so we know that the critical depth is here. Okay, and we get the y2 to the subcritical flow here after the jump. So you must know that how to find the y1 and how to find the y2. So we must use the conjugate depth that I show you at the previous slide. Okay, y1 over y2. Again, that's the conjugate depth. Okay, so energy losses is calculated as EL. Okay, is equal to E1 minus by E2. Okay, this is the basic equation to find the energy losses in hydraulic jump. Okay, so E1, we know that this is the equation for E1, and E2 is this is the equation for E2 using the Y1. E2 is using the Y2. Okay, so we get the equation here. Okay, for rectangular channel, it can be simplified as this one from this one, because we know that the rectangular channel, so Q is equal to Q over B. Okay, so we use the Q here, and it can be simplified as the Y here. Okay, so we get the real equations for rectangular channel until we get this one. Okay, so this is the equations for rectangular channel for energy losses in hydraulic jump. So this is the equation to get the L is energy losses. Okay, energy losses is equal to y2 minus by y1 power of 3 divided by 4 times by y1 times by y2. So this is, so don't worry, so this equation is given. Okay, so no need to remember that. So you must know that if in test or in final this equation is given, so you must do this equation to find the energy loss in hydraulic jump. Okay, so power due to energy losses, so this is the equation for power. Okay, and height of jump. Okay, the height of jump is given as this one, and the length of jump. Okay, the length of jump based on Froude number. Okay, upstream of the jump, Froude number. If the Froude number is less than 5, so we use the length of jump is 6.9 times by y2 minus by y1. Okay, if the Froude number more than 5, so we use this equation. Okay, 6.1 times by y2. So this is for Froude number more than 5 and less than 5. So we use this equation to find the length of jump. Okay, so we look at the example activity 4.2 here. Okay, a spillway discharge flow at a rate of 7.75 meter cube per second per meter. Okay, at the downstream horizontal apron, the depth of flow was found to be 0.5 meter. What is the tailwater depth is needed to form a hydraulic jump? Okay, to find the hydraulic jump. If a jump is formed, find its types. Okay, types of jump, length of the jump, head loss, and also the energy loss as percentage of the initial energy. Okay, so find the type of jump. So we know that Q is this one given here, and Y1 is 0.5. So we get the Froude number. Okay, first find the Froude number to find the we get the Froude number is 6.999. Okay, so we get the Froude number here. Okay, and then find the conjugate depth. Okay, so y1 is given, so you must find the y2. Okay, so use this equation to get the conjugate depth, and you find the y2 is 4.7. Okay, you get the 4.7 for y2. So okay, so based on Froude number, we know that 6.999. So the jump is steady jump. So we get the steady jump. So the based on Froude number, so we know that the hydraulic jump is a steady jump. So this is the between range of Froude number. Okay. So since Froude number is 6.999, so this is more than 5. So if more than 5, so we use the length of jump is this one. Okay. So we use the equation for the length here. So put all the value here. So we get the length of jump is 28.7 meter. Okay. After we get the length of jump, so we must find the head loss is given as EL. So we use this equation, okay, to get the energy losses. Put all the value here and we get the energy losses here, 7.901. Okay. And initial total energy, to get the initial total energy, E naught here. Okay, so you use these equations. Okay, so initial total energy is y1 plus q squared over 2gy1 squared. So put all the value here, so we get the initial total energy. Okay, so to get the percentage of energy losses, so EL over E naught here. Okay, put all the value here, we get the percent. So 61.99% here. Okay, that is the step by step to find the hydraulic jump, height of the jump, length of jump, energy losses, okay, total energy, and also the percentage of energy losses. Okay, so look at the activity 4.3. So a 25-meter wide spillway is discharging fluid velocity of this one at the depth of 1 meter. Okay, so we find the height of jump and power loss due to the jump. Okay, so there is given the B here. Okay, wide spillway. Meter wide spillway is discharging. So Y1 is 1 meter. Okay, V1 is 30 meter per second. Okay, so Froude number. So first you must find the Froude number because they given all the value of the velocity and also the Y1. So we get the Froude number here. Okay, so you get the Froude number here, 9.578. Okay, and then you must find the conjugate depth because the y1 is given, so you must find the y2. Okay, find the y2, we get this one. Okay, using this equation, conjugate depth. Okay, you must use this equation, okay, to find the y2. Okay, after that, so you must find the height of jump. So height of jump is, this is the equation for height of jump. Okay, put all the value you get and we get the height of jump is 12.055 meter. Okay, and then use the energy losses because the hydraulic jump is step by step. Okay, so this is the example that is always used in your test 2 and also your final. Okay, this is the example question, okay, for hydraulic jump. Okay, that's the step by step. So you get the energy losses and you get the value of energy losses here. Then after that, so you must use the power due to energy losses. Okay, put all the value here. Okay, and put the Q and EL here. So we get the power of energy losses of this one. Okay. After that, after the hydraulic jump, okay, the hydraulic jump is part of the rapidly vary flow. So we now in the second part topic for gradually varied flow. Okay, hydraulic jump is rapidly varied flow. Okay, you must remember that, understand that the hydraulic jump is rapidly varied flow. So now we on the new subtopic, gradually varied flow. Okay, actually gradually varied flow is a steady non-uniform flow in a prismatic channel with gradual change in its flow surface elevation. Okay, so example, drawdown produced by sudden change in channel bed slope. Okay, so from the my slope here is a change to the steep slope. So actually for a gradually varied flow, so this is the sketch of the drawdown, okay, for the gradually varied flow. Okay, and also this is the concept for the gradually varied flow when backwaters produced by increase in bed elevation. So from the mild slope here, milder slope here, so they have the backwater here. Okay, the flow from here. Okay, so they have the backwater computation here. So the M1 here is mild slope. This is the control section, and this is also the control section. So this is actually this is more on theory. Okay, gradually varied flow is more on theory to sketch that the what is the gradually varied flow is in. Okay, it is a backwater produced. Okay, so type of flow. Okay, we know that using the y naught and s naught. Okay, so y naught more than yc and s naught is less than sc. Okay, sc is actually slope at the critical slope. So we know that this type of flow is symbol m is mild. Okay, y naught less than yc, s naught more than sc is the steep slope. Called the symbol of s. Okay, and y naught is equal to yc here, s naught is equal to sc here. This is the critical slope. So this is the symbol fc. Okay, y naught is no infinity, so s naught is equal to 0. So this is the horizontal slope. So the h. Okay, when y naught is infinity, s naught is less than 0. So this adverse slope. So we call the as the a symbol. Okay, so this is the types of slope. Okay, so this is a classification of GVF profile. Okay, actually for the gradually varied flow profile, we must know using the mild slope, steep slope, critical slope, horizontal bed, and adverse slope. So you must know this condition here. Okay, actually for the region 1, region 2, and region 3. Okay, the type 1, M1, M2, M3. I say M1 is for the region 1, M2 is for the region 2, mild at the region 1, mild at the region 2, and mild at the region 3, and so on. Okay, steep for region 1, steep slope at the region 2, and so on. Okay, so this is the classification of GVF profile. So this is the region 1 and the region 2 here and region 3 here. Okay, actually mild, steep, and critical. So actually this region 1, region 2, region 2, we have summarized here at this classification here. Okay, this is the classification of GVF profile, and this is the real profile for the GVF. Okay, gradually varied flow. Okay, they have the region 1, region 2, and region 3. So they have the mild at the region 1, mild at the region 2, and mild at the region 3. And steep at region 1, steep at the region 2, and region 3, and so on, critical. Okay, and also the horizontal H and adverse A here. Okay, so they have no region 1 here, just only have region 2 and region 3. So this is the surface profile for the GVF classification. Okay, all curve in region 1 have positive slope, and all curve in region 2 have negative slope. So this is called the backwater curve and also the down curve. So actually, so you must remember this is for your theory. Okay, okay, so this is also from that the classification. Okay, so occurrence of flow profile. So M1 profile, mild at region 1 profile is occurs due to obstruction to subcritical flow. Example, weir, dam, and other control structures. So the profile extends to several kilometers upstream before approaching the normal depth. So this is the sketch of the my profile, M1 profile. So Y more than Y naught, more than YC. Okay, this is the profile here. Okay, actually this is for theory. Okay, M2 profile occurs when there is a sudden drop. They have the sudden drop here. Okay, in the bottom of the channel, constriction of channel or channel outlet into the reservoir. So this is the M2 profile. Okay, you must remember this one. Okay, no need to remember all the everything. So you just remember that this basic question. Okay, to know that the M2 profile. Okay, and also this is a M3 profile occurs when supercritical flow enters a mild slope, enters the mild slope here, and flow from a spillway or sluice gate to a mine channel here. Okay, from the spillway or sluice gate here. Okay, this is sluice gate. So we enter here. So we have the flow, okay, from spillway to a mine channel. So this is M3 profile. Okay, and the S1 profile here occurs when supercritical flow change to pole. So you just remember this one. Okay, no need to remember that. Okay, no sketch here. Okay, this is actually this profile is from the table that profile that I given in the previous slide. Okay, so this is a one by one, okay, to show you about the S1, S2 and so on. Okay, this is S2 here, occurs when flow from reservoir enters steep slope or when there is a change from mild slope to steep slope. So you just remember this one. Okay, so from the reservoir here, okay, this is the reservoir. Okay, this is the reservoir here and enter to the steep slope here. So this is S2 profile. Okay, so S3 profile occurs when flow from reservoir enters steep slope or when there is a change from mild slope to steep slope. So this profile is of a shorter length here. Okay, from the reservoir enter a steep slope or from the steeper slope to the mild slope to the steep slope here. So this is the S2 profile here. Okay, just remember this one. Okay, so this is C1 and C3 profile is for the critical. Okay, highly unstable airily because this is for the critical. Okay, at the region 1 and critical at region 3. Okay, critical at the region 1, critical at region 3 is the profile here. No profile here, you just remember this one. Okay. Okay, so H2 and H3 is horizontal because this is the horizontal bed here. Okay, occurs when the bed of my slope becomes flatter. There is no region 1. Okay, so just only have H1 and H2 and H3 for this region 2 and region 3 only for the horizontal. For the adverse, also only have at the region 2 and region 3. So this is the occurs when flow is on adverse slope, which is rare. This profile occurs with a short length here. Okay, so this is the profile for the GVF. Okay, so look at the activity here. Determine the type of profile for the, actually for this example, they just give you the figure here. Okay, so from this figure you must explain that which type of profile of this flow. Okay, from A and also the B here. Okay, from the A here you must know that which type of profile of this figure. Okay, so just give you the figure here and you just explain what is the type of profile. Okay, so actually for this one, so they have the YC here. Okay, you just actually Y naught is more than YC is more than Y naught here. So this is the S. Okay, at the zone 1 here is equal to S1 and the zone 3 is S3. So is the, so you just explain about this here, so you know that. Okay, so this is the explanation of this figure. Okay, and this is the explanation of this figure. Okay, so this is actually 5 marks. Okay, actually this is the example of the previous final exam questions. Okay, so this is like this one. They just give you the figure. Okay, the sketch, the figure here. You must explain what types of this flow profile. Okay, so you just explain this one and explain the one, so you know that. Okay, so activity 4.5. So a rectangular channel with bottom with 4 meter and bottom slope, okay, 0.0008 has discharge of 1.5 meter cube per second. Along the gradually vary flow in the channel, the depth at the section is found to be 0.3. Assuming many and determine the type of GVF profile. Okay, so you must calculate. Okay, now you look at this one. So you must use the equation in chapter 2. Okay, to find the Y naught first. Okay, so you must know that Y naught. Okay, so you must use the equation that you have learned in chapter 2. Find the Y naught. Okay, so use this Manning. Okay, Manning Okay, this is the rectangular channel, so you put all the value and the equation of the rectangular for the A and R here. Okay, and then you find the y naught. Okay, actually to find the y naught, so you must use the try and error method at the chapter 2. Okay, so and then you find the y naught here. Okay, and after get the y naught, so you must find the yc. Okay, yc you must use the equation in chapter 3. Okay, now all the equation that you have learned in chapter 1, chapter 2, and chapter 3, you must use again in chapter 4, 5, and 6. Okay, so now your chapter 1, chapter 2, chapter 3, you must remember what equation that you will use in chapter 4 and chapter 5, also chapter 6. Okay, so use the equation in chapter 3 to get the yc. So and then you get the yc. Now after you get the y naught and you get yc, you just explain this one. Okay, so you get this one. So this is the actually this is 6 marks. Okay, 6 marks for this question. Okay, so they just try to find the y naught, try to find yc, and then you must explain which type of profile for the GVF. Okay, that's all. Thank you until we continue in part B. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh.